Of the numerous techniques in the modern hacker's arsenal, few are as deceptively simple yet profoundly powerful as Google Dorking. The methodical use of advanced search operators to uncover sensitive information accidentally exposed on the web, a practice that transforms the world's most popular search engine from a simple information retrieval tool into a potent reconnaissance weapon that can reveal everything from unprotected database files and exposed administrative panels to confidential documents and vulnerable network infrastructure, all without ever sending a single packet directly to the target or triggering a single intrusion detection alarm. Also known as Google hacking, this technique leverages Google's incredibly comprehensive indexing of the public internet to find digital breadcrumbs that organizations and individuals never intended to make public. Using specialized search queries that exploit the precision of Google's search syntax to filter billions of web pages down to those containing specific file types, directory listings, login portals, or even raw configuration data containing passwords and API keys. The foundation of Google Dorking rests on mastering a relatively small set of powerful search operators that, when combined creatively, can expose staggering security oversights. The site operator restricts searches to a specific domain or top-level domain, allowing an attacker to focus exclusively on a target organization's digital presence. The file type, or ext, operator filters results to specific file extensions like PDF, XLS, SQL, or log, often revealing databases, financial spreadsheets, or system logs that should never be publicly accessible. The in-URL and in-title operators search for specific text within web page URLs and titles respectively, invaluable for finding administrative interfaces with default passwords or directory listings that expose entire folder structures. The in-text operator searches for specific words within the body of a web page, perfect for locating documents containing phrases like confidential or for internal use only, while the cache operator can retrieve older versions of web pages that may contain information since removed, but still preserved in Google's cache. The practical applications of these operators in malicious hands are both extensive and alarming. A simple query like entitle index of parent directory password can uncover improperly configured web servers displaying directory listings that include critical system files like the Linux password file, while filetype.sql intext insert into values might locate database backup files containing not just table structures, but actual user records with personal information. Hackers targeting specific technologies can use dorks like in-URL, PHPMyAdmin, in-title, PHPMyAdmin, to find installations of the popular MySQL database management tool that may be exposed to the internet with weak or default credentials, or Apache 2.4.41, Ubuntu. Server at, entitle index of, to identify servers running specific software versions with known vulnerabilities. Perhaps most dangerously, searches like AWS Access Key, AKIA, can potentially uncover Amazon Web Services access keys hard-coded into public documents or code repositories, granting attackers potential access to cloud infrastructure and storage buckets, while API key, XAPI key, file type, ENV might locate environment configuration files containing various service credentials that developers accidentally made public. The reconnaissance phase of an attack often begins with these Google Dorking techniques, as they provide a risk-free way to gather intelligence about a target's digital footprint, exposed services, and potential security weaknesses without any direct interaction that might trigger security monitoring systems. Beyond simple file discovery, Google Dorking enables sophisticated vulnerability identification. Searches like in-URL, viewer, HTML, file TURL can locate instances of directory traversal vulnerabilities in web applications, while in-text, error in your SQL syntax file type. PHP might find websites that display detailed database error messages revealing table structures and potential injection points. For industrial espionage or competitive intelligence, queries like confidential, proprietary, filetype.pdf site, target company. Com can uncover sensitive documents that should have been restricted, while password login filetype .lsx site .edu might locate spreadsheets containing institutional credentials on educational domains. The practice becomes particularly dangerous when combined with other open-source intelligence (OSINT) techniques. Cross-referencing employee names found on LinkedIn with document metadata uncovered through targeted Dorking can build comprehensive profiles for social engineering attacks, while locating network diagrams or infrastructure documentation through carefully crafted searches can provide blueprints for more targeted network intrusion attempts. Security cameras represent another common target, with dorks like INURL Viewer, Tamil Mode Motion, or in title Webcam 7 Live View, often revealing unsecured video feeds from surveillance systems worldwide, demonstrating how physical security can be compromised through digital reconnaissance. The evolution of Google Dorking has paralleled the expansion of Google's indexing capabilities. As the search engine began crawling beyond traditional web pages to include PDFs, PowerPoint presentations, and even IoT device interfaces, the potential attack surface exposed through Dorking expanded exponentially. Today, specialized Dorking repositories and databases like the Google Hacking Database, GHDB, maintained by the Offensive Security Team, contain thousands of curated queries categorized by discovery type, from vulnerable files and error messages to sensitive directories and exposed devices, providing both attackers and defenders with a comprehensive toolkit for finding security misconfigurations. Defensively, these same techniques become invaluable for organizations conducting their own security audits. System administrators can use identical search queries to proactively discover what information about their infrastructure is publicly accessible through Google's index, allowing them to remove sensitive documents, secure exposed interfaces, and properly configure robots.txt files to prevent sensitive directories from being indexed in the first place. The ethical dimension of Google Dorking occupies a complex space in cybersecurity. While the technique itself merely uses the public interface of a search engine as intended, the intent behind its use determines its legality and morality, with unauthorized access to systems through discovered credentials or exploitation of found vulnerabilities representing clear criminal activity even if the initial reconnaissance involved nothing more than clever searching. Protecting against Google Dorking requires a multi-layered approach, beginning with proper configuration of web servers and applications to prevent directory listings and ensure that sensitive files are stored outside web-accessible directories. Organizations should implement thorough robots.txt files to guide search engine crawlers away from administrative sections and sensitive areas, though it's crucial to understand that robots.txt is a suggestion rather than an enforcement mechanism, and determined attackers will simply ignore it. Regular monitoring through Google Alerts for company-specific sensitive keywords can help identify when confidential information appears in search results, while automated scanning using the same dorking techniques that attackers employ allows security teams to discover and remediate exposures before they can be exploited. For developers, security awareness about the dangers of hard-coding credentials in source code and configuration files is critical, as is implementing proper error handling that prevents detailed system information from being displayed to users. Ultimately, Google Dorking remains one of the most accessible yet underestimated attack vectors precisely because it requires no specialized tools beyond a web browser and knowledge of search syntax, making it a potent reminder that in the digital age, sometimes the greatest threats come not from sophisticated malware or zero-day exploits, but from simple information disclosure that can be uncovered with nothing more than a carefully crafted search query, highlighting the critical importance of digital hygiene and the assumption that anything placed on a publicly accessible web server will eventually be found by someone, whether through intention or accident.